So for section 4.1, we're talking about the applications of the first derivative. So I have a diagram, and hopefully you were able to print out the notes or at least pull them up. And we can see from this diagram, on this interval, my function is increasing. And again, on this interval, my function is also increasing. So I have it's increasing here, and it's increasing here on this interval. And then it's decreasing in this interval. And then what I have both here and here are horizontal tangents. So that's where the graphs change directions at. So those are the horizontal tangents. So the first, excuse me, the first thing that we're really going to be talking about, our first theorem for this section, is how do we know when graphs are increasing or decreasing by using the derivative? Well, if my derivative is positive on any interval, then it's increasing. So positive on the interval tells me that the function is increasing. If it's negative on the interval, then that tells me that the function is decreasing on that interval. And if it's just 0 on some interval, then that tells me it's constant. So here's an example of that last one. So maybe I have a graph and it might be increasing, and then at a certain point it just levels off, and then maybe it decreases again. So it would be, my derivative would be positive on this interval, it would be 0 on this, and then it would be negative here where my function is decreasing. So I have f of x is equal to x squared, and I want to know where this thing is increasing and decreasing. So first I take the derivative. So just by inspection, if I plug in a negative value in here, I get something that's negative. If I plug in a positive value in here, I get something that's positive. So if I have x less than 0, that's going to be decreasing because I get a negative value. And x greater than 0, when I plug in something like 1 or 2, I get something positive. So it's increasing on that interval. So the steps that we're going to use to determine whether the function is increasing or decreasing is, the very first thing we have to do is find where the derivative equals 0 or where it's undefined. And those values, we call them C. Those are the critical numbers. or critical values. Means the same thing, it just depends. So I'm going to use them interchangeably because you'll see both of those as you move forward. So when they use the term critical values, they use a CV, and critical numbers, CN. Alright, so that's the very first step. Then we select the test point. Inside the intervals. Of the C values. In that interval, if that test point is positive, so I'm just going to use X right here for a test point. If it's positive, then the function is increasing. If that test point is negative in the interval, the function is decreasing. So again, we have to find where it's 0 or undefined, and then we're going to just pick stuff in the interval, and I'll show you an example in a second that we're actually going to be evaluating those at. So I have 1/3 x cubed plus 1/2 x squared minus 12x plus 5. So step 1, take the derivative, and we get x squared plus x minus 12. And then I have to see where that's 0 or undefined. So there's nothing that makes this undefined, so I just need to know where it's 0. So that factors to x plus 4 times x minus 3. And then set each of those equal to 0. So I get two solutions, -4 and a +3. So what I'm going to do is make my number line. And I have my -4 and 3. Those are my critical values. And now I'm just going to plug stuff in the intervals and then see whether they're positive or negative. You can pick any number that you want. I don't want to pick anything too big and make my life harder. So when I pick my critical numbers, I'm going to try and make them as small as possible. So as long as something's less than -4, I can pick anything. So I'm going to pick -5. For this interval, I'm going to pick a 0. And for this interval, I'm going to pick 4. So those are the test points. These values, the critical values, are the only place where you could possibly change from increasing to decreasing. So I don't have to worry about there being the graph changing directions anywhere else. This is it. These tell me all the places where it's possible. So when I plug in -5, I'm going to plug it into here just because I can do the calculations a little bit easier in my head. So if I plug in -5 here, I would get -1 times -8. So that gives me a positive value. When I plug in 0, I get +4 times -3. So that gives me a negative value. And when I plug in 4, I get 8 times 1. So that gives me a positive value. So that tells me that my function is increasing on the interval from -∞ to -4. And then again, and that is just union. That's just the way to put them together. So again, from 3 to infinity. And my function is decreasing on the interval from -4 to 3.